Hello, my name is Vincent. Thank you for being here, and I hope you're fine and comfortable. The topic today is of the utmost importance: how to reduce the carbon footprint of a retaining wall. We all know retaining walls. They're used as temporary or permanent structures along roads, railways, bridge abutments, and arch structures. They can basically be found everywhere. So it's quite useful to ask ourselves, what is the best solution in terms of carbon footprint, right? There are three existing solutions. I guess you know them, but just to be sure. The gravity retaining wall, its name speaks for itself. The weight of its major component, mass concrete, maintains the stability of the wall against earth pressure. The cantilever retaining wall, with its L shape, it is mainly composed of reinforced concrete. The weight of the earth on the horizontal part of the L anchors the structure. The vertical part of the L works in bending to retain the earth pressure. Last but not least, the reinforced soiled wall, which combines two things: compacted granular backfill material and soil reinforcement with precast concrete facing panels. We'll focus on the VSoL solution by VSL and its two types of reinforcement systems, the steel ladders and the polymeric strips. So now that the introductions are made, let's shift to the core of our topic. What is the best solution in terms of carbon footprint? Because methodology is key, and I am adamant about this, let's compare what is comparable. To be objective, the comparison is based on an identical functional design such as loading conditions and design life requirements. Are you ready? First, let's look at the concrete volumes. Compared to the gravity wall and cantilever wall options, the reinforced wall uses 50 to 90% less concrete, depending on the height of the wall, since its main structural component is soil backfill. Now, what about the steel quantities? Once again, with soil as major component and also with 50 to 75% less steel, the reinforced soil wall has the best environmental impact performance compared to the cantilever. Finally, let's envision a bigger picture and compare the global warming potential through embodied carbon emissions at different wall heights. We're comparing backfill soil, concrete, this is for gravity and cantilever wall. For reinforced soil wall, this only includes precast panels, including concrete, steel, rebar, and connections. Reinforcing steel, meaning rebar for the cantilever, and soil reinforcement for the reinforced soil walls. And let's not forget construction activities and material transportation. For this exercise, let's say that transportation is based on 100 kilometers for the prefabrication and transportation of wall-facing panels, although it could easily be cast on-site as well. And also 10 kilometers for the backfill, as well as for the concrete pouring, for gravity and cantilever alternatives only. As for VSoL, it is just about transportation of precast panels. So, as indicated on the graph, I think we have an answer to our initial question. What does the graph indicate? First observation, reinforced soil walls like VSoL result in lower environmental impact than traditional earth-retaining solutions. It's due to the use of backfill as the principal structural component rather than concrete and steel. The VSoL solution only uses concrete for the thin facings. The use of waffle panels, which are shaped to optimize material quantities, can also be an interesting solution. You can note as well that concrete panels are most of the time prefabricated in a controlled environment, with a huge optimization in the production ratios, cycles, material wastage, energy and water consumption. This also contributes to the reduction of carbon footprint. Lastly, VSoL walls generally make use of adequate fill materials sourced on the site, or even recycled or marginal fills, with the aim to continue improving the environmental efficiency. Polymeric is the best low-carbon solution as it uses much less steel for the same strength requirements. This solution can even be less carbon emitting when void-formed connection is used. Second observation. The higher the wall, the bigger the benefits. They increase markedly with walls about 5 meters high or more. In terms of greenhouse gases emissions, at 10 meters, VSoL is 4 times less carbon emitting than gravity, and 3 times less emitting than cantilever. The difference becomes much more significant with walls higher than 10 meters. VSoL will be almost 5 times less carbon emitting than a traditional solution. And the polymeric reinforcement is also presenting a much better solution in terms of carbon footprint, between 8 to 9 times less emitting. Did I forget something? Yes, the carbon impact of the maintenance activities. They were found to be negligible when comparing to the full scope of the environmental analysis. And they're basically just about transportation with electricity and diesel consumption. However, demolition is key here. And reinforced soil walls are significantly less impactful than gravity and cantilever solutions. So there's no need to use heavy machinery, and the demolition can follow the same step-by-step procedure as the construction sequence. And maybe even to allow the reuse of some of the components. That's it. Of course, the choice of a retaining wall depends on many criteria, and now the carbon footprint can be an important indicator to consider. Well, I hope I was clear enough today. For more information, please do not hesitate to contact VSL, who is a specialist in the design and build of these low-carbon solutions. Thanks for watching.